probability is something we all know. It is something that we all deal with on a daily basis, because life consists of chances and life consists of uncertainty. So just think of something simple like the weather. The weather changes all the time, and it can be so many different things. It can be the sun shining, it can be rain, can be partly cloudy, it can be a storm, it can be snow, it can be so many different things. So probability has to do with the chance of something happening or the chance of an event occurring. Okay, well, Coco Bali, I'm going to pause and let you ask your question. Go for it.
Hello, ma'am.
Hi there.
Ma'am, I just wanted to answer what was probability.
Okay, thanks for Coco Bali. Can you give us an example?
Ma'am, it's like when they roll a dice or they toss a coin. So how likely is it to get an odd number, or what is the outcome?
Yes. Okay, nice. So you know that word outcome already. That's good. Okay, so another example that I thought of this morning as I was getting ready for work was I have so many tops and t-shirts in my cupboard, and I was trying to choose a top to wear today, and I chose this pink one, but in the cupboard was a blue one, a white one, quite a few black ones, a gray one. So it's like working out what are the chances of me actually, from all the tops that I have, putting on this pink one. And if you think it might be easier for you because you've got a uniform, so the chance of wearing something different every day is quite low. But if you had to not wear a uniform, you will look different every day. So that is also another example of probability. But the one that gets used quite a lot is the tossing of a coin. Okay, so if we think of tossing of a coin, what do we get? A coin has two sides. Pop it in the chat. What are those two sides called? What are those two sides of a coin called? Pop it in the chat if you know. This is our first call to participate, everyone. Heads and tails. Yes, good. Heads and tails. So if you start a soccer game or a rugby game, netball game, any game, you toss a coin, right? To see which side is going to start the game. So you either call it heads or tails. So that tossing of the coin is an activity or an experiment. Okay. So all we do really in probability is that we have different names for certain things. Okay. So you just have to know some of the names. And by the way, if you are listening to the lesson and you want to take a screenshot of any of the notes that are on the screen, feel free to do so. You are very welcome to take screenshots. Okay. So Peewee, I'm just going to get through the next bit, and then I'll give you a chance to ask your question. You can also pop it in the chat. Okay. So tossing of a coin is called an activity or an experiment. So when I toss a coin, there are two possibilities. Two things can happen. I can either get a heads or a tails. Okay. And those things have an equal chance of happening, right? Unless the coin is rigged, but most coins are not rigged. Okay. Those things can happen equally. There's a fair chance. We call it a fair chance because it is a fair coin. Okay. Another example is with the dice. A dice, throwing of a dice. Now, think about it. How many options have we got when we throw a dice? How many options can we have? How many things can happen? That's it. 6 different things. We can get 6 different numbers. Well done, everybody. Good. So throwing a dice is also an activity or an experiment. And each number on the dice has an equal chance of landing face up. and that is called a fair dice. Okay, so again, if a dice is rigged, which doesn't really ever happen, unless someone's cheating, then there's a fair chance you're going to throw that dice and it's going to land on 1, 2, 3, 4, 5, or 6. Okay, and there's an equal chance of any of those happening. Okay, now, so that's the first word that I need you to know is activity or experiment. And this idea of equal chance. Right. Now, the next word that you need to learn for probability when we are talking this language of probability is an event. So getting tails when tossing a coin is an event. Okay, so that is also an important word, event. So I'm going to toss a coin. It can land heads or tails. So if it lands on tails or getting tails, that is called an event. Right. Okay, give me a thumbs up if you are happy with everything we've said so far. Pop it in the chat. Let's see how everyone is so far. Put a thumbs down if you're not happy. But so far, we've just really discussed some things that we all actually really already know. Lechlomile, I'm going to give a chance for questions in a few minutes, okay? So then just put your hand up when I say, are there any questions? Okay, well done. Right, now, when we are tossing a coin or a dice or something, we can have different outcomes, okay? So our event or our activity, rather, is tossing a dice or a coin, and then you can have outcomes. And all of those outcomes form the sample space. Okay, so the sample space is everything that can happen. So let's think about it like this. For example, you throw a dice and you get a 6. So we're going to say an activity, the activity here is throwing the dice. If you do not understand, rather just rephrase and be specific about what it is that you don't understand. That way we can help you much easier. Okay, so put in the chat, I don't understand, whatever it is that you don't understand. Okay, so, or ask a question. What do you mean when you say, etc. Okay, it just helps us to really answer your question quickly and efficiently. Okay, so our sample space, when we are throwing a dice, are all the possible outcomes. So what are the possible outcomes on a dice? Pop them in the chat if you know. What are the possible numbers that we can get on a dice? All of them. There are 6 of them, but what are they? List them all. There we go. Fence got it. 1, 2, 3, 4, 5, and 6. That is our sample space. Okay, so for those of you who listed only one number, our sample space consists of all the possibilities. Okay, nice. I see a few people getting that right. Okay, what is our event? Our event is the thing that we are looking at. Throw a dice and get a 6. So the event is getting a 6. And a favorable outcome is what is the outcome that we are going to be happy with? And that is also getting a 6. Okay, so make sure you understand about activity, sample space, event, and favorable outcome. Okay, so favorable outcome is the thing that you want to happen, that you're going to be happy with. The sample space are all the possible things that can happen. And your one option that you're looking for, the thing that's going to make you happy, is getting a 6. Okay, Right, so that's our sample space and listing outcomes and all of that. Okay, now we get to the actual probability and the words we use to describe things, describe the probability of things, of events. Okay, so I want you now in the chat to write something for me. Think of something that will always happen. Pop it in the chat. What is something that will always happen? Ah, nice. Day and night, the sun rising. There we go. There we go. Come, let's think of some more example. Think of something that will always happen. Breathing. Yeah. As long as we are alive, we'll breathe. Blinking. Oh, I like that one, Danao. Oh, Miss Coco will always be fabulous. There you go. Birthdays. Okay. Eating, the sun.
I think somebody said load shedding. I don't believe that. One day, guys, one day we will be rid of it. I have faith in our country.
Yeah. Heart beating, moving around, talking. Seasons. I like that too. Okay, cool. So you guys get it. Things that will always happen. Okay, now think of an event that is impossible. What is something that is impossible? Pop that in the chat. Hurdles. Oh, nice. Tsunamis in Joburg. Cats and dogs raining. Walking on water. Oh, blood raining. Oh, flying. Snowing in Pretoria. Time stopping. Wonderful. Uncooking the turkey.
Walking
Animals
without your legs
talking.
moving.
Time travel,
that.
not going to school. Wonderful. These are very nice examples, guys. Well done. Okay, now this one is a little bit more tricky. Think of an event that is not impossible, but uncertain. Something that is not impossible, but you're not entirely certain that it is going to happen. Load shedding stopping. I think load shedding just fits into everything. Okay, a tornado in Joburg. That's very nice. Yeah, that's a good one. Winning the lottery. It's not impossible, but you're not certain. Nice. Living on Mars. Bafana Bafana. But Banyana maybe, hey? Banyana's on fire at the moment. Time travel, wildfire. Okay, last one. Think of an event or events. Let me just change that to an event that, no, it should be think of events that are equally likely. What things are equally likely to happen? Okay, so it must be two things that are equally likely to happen. Rain or shine. Coin flipping, nice, yeah. Day and night are also equally likely, yeah. Lose a soccer match and be happy. I think one would be unhappy. Passing and failing maths, equally likely. I hope we're going to tip the balance there. Boy or girl, that's right. Both on even numbers, eating and swallowing. Okay. Left or right? Okay, wonderful. Right, so let's talk a bit more about these words that we use to describe probability. Maths teachers being, they're never absent, eh? Like maths teachers are always just at school. Okay, so here's our probability scale, right? So we always talk of probabilities being between 0 and 1. And let's look at these words: likely, impossible, even chance, certain, and unlikely. And let's put them in order. So where will we start? By saying, let's choose this word, impossible. Where are we going to place that? That is probably going to go, no, impossible. If something is impossible, yes, it's going to go at 0. Nice, guys. And let's go with the next one, unlikely. Where is that going to go? Unlikely. Okay, just check, because we also have even chance and certain. So I think certain is probably going to go all the way at 1, because if something is certain, then it's like you're saying there's 100% chance of this happening. Okay. What about even chance? I think it will go here in the middle. An even chance. Even chance is like a 50-50. Okay, so that goes in the middle. Certain goes 100% at number 1. And then likely, what is left? We are left with likely and unlikely. I think likely is also going to go close to 1, and unlikely is not impossible, but it's not entirely certain. It's unlikely, but it's not, sorry, it's unlikely. It's not impossible, but there's still not a big chance that's going to happen. Okay. So I see some of you are putting down percentages for this, and that's great. We're going to get to that now as well, because we can use numbers to represent probabilities. So what numbers do we use? Okay, so first of all, when something is certain to happen, the probability is 1. For example, the probability of rolling a number greater than 0 on a dice is 1. You are going to get a number greater than 0 on a dice. That's 100% probability. Okay. Where they belong and where they fit in on a number line. Okay, it's just because we work from 0 to 1. So this is about halfway through. So I would say that that's a half. And this is about 3/4 of the way. So that makes it a lot more likely that something is going to happen. And this is going to be about 1/4 of the way. So it is not impossible, but it is unlikely. Okay. But we are going to talk more now about how we use numbers to represent probability. Okay. So probability is never less than 0, since an event cannot be less likely than impossible. Okay, so our lowest probability on the probability scale, if we look at this, our lowest probability is here. That is 0. We don't go lower than 0. And our highest probability is 1. That is when something is 100% certain. Everything else falls in between. Okay. All right, how's everyone doing? Let's do a quick check-in. Put a thumbs up in the chat if you're feeling good. Put another emoji in the chat if you're feeling something else. Let's see. What are the chances that everyone is going to put a thumbs up? Okay, so Sisipo has a question. I'm going to do a quick question with Sisipo. Go for it. Okay, so Sisipo, if you're not going to ask your question, we are going to unfortunately go ahead. Remember, guys, please be quick when you ask your questions and be sure of your question. Okay, and remember to listen carefully and to follow along carefully as we explain. Okay, now let's talk about our next word. So we've learned a few words so far. We've learned about an event, and we've learned about the different words to describe probability. So the next one is the theoretical probability. So a theoretical probability is the same as the actual probability, okay? And that is just basically saying, and this is something that you can take down because this is like the basis of probability. It's the number of outcomes that that you're looking for. So if you are looking for your event, whatever it is that you want to happen, so you're rolling a dice and you want a 5 on the dice, that's your event. But on the dice, there are 6 possible outcomes as we determined earlier in the lesson. Then the total number of outcomes is in the sample space. Okay, so let's do this. Let's say, what is the probability of getting head when a fair coin is tossed? Write the answer as a fraction in simplest form, as a decimal, and as a percentage. And that is how we can write all probabilities, as a fraction, a decimal, and as a percentage. Okay, so what is the probability? So first of all, let's think about this. What are our outcomes? How many outcomes do we have? We have a head or a tail, and that gives us 2 outcomes. We want to hopefully get heads. So that is one of the 2 possible outcomes. So the probability of getting a heads when we toss a coin is 1 out of the 2. Okay, so the one thing that we are looking at, 1 out of 2. And that we can now write as a decimal, which is 0.5, and we can write it as 50%. Okay, so we write our probabilities as fractions, decimals, and percentages. Okay, remember you can take screenshots, it's much quicker. Okay, now let's look at this one. A regular 6-sided fair dice is thrown once. Okay, I'm going to ask you guys to read this question. And for those of you who are new, we do this thing where we post this little glasses face when we are done reading. Okay, so read the question, read all of it. Don't do it yet, we're going to do it together, but I just want you to read it. And when you're done reading, post your reading emoji so that I know that you're done. Yeah, just read, guys. It's all coming. Don't worry. I just want you to read. Come, we need way more reading faces than that. We are 140 strong in this class this evening. I need 140 reading faces. Oh, stop crying. There's nothing to cry over here.
Emilio, that's the wrong emoji.
Yeah, wrong emoji. We want smiley faces and glasses faces. Nice. There we go. Lots of reading faces. Okay. Now, A regular 6-sided dice is thrown. List the sample set. Okay, pop it in the chat. What is the sample set? In other words, what are the possible things that can happen when you throw the dice? What numbers can you get? We've done this before. 1, 2, 3, 4, 5, 6. Excellent. Well done. 1, 2, 3, 4, 5, 6. How many elements are there in the sample set? How many elements, guys? How many elements? Count them. 1, 2, 3, 4, 5, 6. How many things are there? There are 6 elements. 1, 2, 3, 4, 5, 6. Nice. Okay, so elements, not such a big deal. It's just how many things there are in the sample set. And then list all the favorable outcomes for getting a score of 3 or more. Okay, so we want, remember, favorable is the thing that we want. So what are the possible favorable outcomes for getting a score of 3 or more? 3 or more, okay? So it includes 3, 3, 4, 5, and 6. Okay, good stuff. How many favorable outcomes are there? How many of those are favorable for us? Count the number of favorable outcomes. There's 4. There we go. Okay. Now, what is the probability of getting a score of 3 or more? Give your answer as a fraction in its simplest form, as a decimal, and as a percentage, correct 2 decimal places. Okay, so what is the probability? Now, think carefully. We want a score of 3 or more. So how many options is that? It's not 50. It's not 50. Okay, I'm starting to see some right answers here. How many favorable outcomes are there? 4. Let's go back to what we said, how we calculate probability up here. We take the number of outcomes that we want, which is the 4. How many possible outcomes are there? 6. So we say 4 of the ones are favorable of the 6. So that's 4 out of 6. And we are going to simplify that into a fraction. So into its simplest form. So that's 2 over 3. What is that as a decimal? How do we convert to decimal? We just use the calculator. 2 over 3 times 100. Or you just go 2 over 3. 2 divided by 3. That gives me 0.67 if we round to 2 decimal places. Good job, everybody. And now we times that decimal by 100 to get our percentage. Okay, 66.67. Okay, if you've got your hand up, be ready with your question, okay? Right, I'm going to go with Inam. Yes. Ask your question, Inam.
Ma'am, can you hear me?
Yes.
I was gonna ask you to repeat the last question, explaining the last question.
Okay, which part? Which part are you lost?
Just finding 4 over 6.
Okay, so we have 4 favorable outcomes from question C because we are looking for a score of 3 or more. So that can be a 3, a 4, a 5, or a 6. There are 6 total outcomes. There are 6 things that could possibly happen when you throw that dice. You can get a 1, 2, 3, 4, 5, 6. We are just looking for 3, 4, 5, or 6. So the probability of that is 4 divided by 6.
Okay, thank you, ma'am. I understand.
Okay, Mawande, you next.
Ma'am, I wanted to ask, for the decimal places, does the question tell us that we should round off to how many decimal places, or it's always 2?
Yeah, the question tells you. If it doesn't tell you, stick to 2 decimal places. Okay. Right, guys, I see a few of you need to work on your rounding. Hey, it is 66.67. We round to 2 decimal places. Okay, now let's practice writing these probabilities a bit more. The letters from the word probability are placed in a bag and one is chosen at random. Find the probability of choosing the letters below. Okay, so the first thing we have to determine is how many outcomes there are, and then how many favorable outcomes there are, and then we write that as a fraction. I'm going to help you with the first one, and then I want you to try the next one on your own. Okay, so how many letters in probability? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I choose a letter from the word probability, there are 11 ones to choose from. So there's 11 outcomes. I am looking for a letter B. So how many B's are there? I count 2. I count a B and another B. So 2 of the 11 letters are my favorable outcomes. So it's 2 out of 11. And that's the probability of choosing a letter B. Okay. Now I want you to do the next one, following that same logic. A consonant, so you guys know what a consonant is, right? It's a letter that is not an O, an A, an I. Those are vowels. So a consonant, and then for C, the letter Q. Okay. Some of these Watobians are nice and fast with their answers, already saying 7 out of 11. Okay, so we know that there's 11 outcomes, 11 possibilities. How many of those possibilities are consonants? 1, 2, 3, 4, 5, 6, 7. 7 out of 11. Nice. Let's do the next one, the letter Q. We do not see the letter Q in probability, so not happening. That's it. 0 out of 11. It is impossible. Yes, Posiswe. Ask your question.
Hi, Miss.
Hi.
Hi. I don't understand how we got 7 over 11.
There's 7 consonants in the word of probability. P, R, B, B, L, T, and Y.
Okay.
So of the 11 letters, 7 of them are consonants. So the probability of choosing a consonant is 7 out of 11.
Okay, thank you, Miss.
Okay, right, let's go on to the next question. This is question 1. Question 2. Let's do question 2. Pop your answer in the chat as soon as you're ready. A bag contains green and red counters. There are 5 green counters and the remaining 3 are red. When a counter is picked at random, what is the probability that it will happen? Random means there's no pattern to it. You're just putting your hand in the bag and you're choosing a counter. Yeah, you can just write 0, it's fine. Okay, pop your answer in the chat. So first of all, how many counters do we have overall? There are green ones and red ones. Guys, read the question carefully. Okay, good. Okay, if you said 5/8, I want a volunteer to raise your hand and tell me how you got 5/8. It's the right answer. I just want to hear from the class, someone who got it right. Okay, Masejo, go.
Ma'am, I took the amount of, I added the 5 green counters and the 3 which are red, and it gave me 8. And since they asked the probability of which are green, I said 5/8.
That's it. So the green ones are our favorable outcomes. Our total, there are 8 counters altogether, so that gives me 5/8. Okay. Right, let's go to question 4. Nicely said, Masejo. So in a class of 30 students, 7 students only have a cat and 8 students only have a dog. A student is chosen at random. What is the probability that the student only has a cat? Pop your answer in the chat. Okay, now we are catching on, I think. There we go. 7/30. Okay.